Okay, today guys we are going to talk about graphical limits, and limits are kind of what you would think of in life as being a limit. You have a limit to how tall you are going to be. You have a limit to how much you can eat. But all of these things can, that thought process anyway, can be applied to what we're talking about here in math. And so functions have limits. Some will not go any higher than 5. Some will not go any further right than -2. Something to that effect. But things are limited graphically as far as boundaries that they approach or touch, and that's it. So notationally, what does this look like? You're going to see a new notation. It's going to be written limit, then it's going to have a subscript, X, arrow, and then I'm going to put C, but that will be a number. And then on the regular line, you will have some function, and it will equal something. And the way that we are going to read this is the Y values approach L as X approaches C. That's what this means. As we get close to whatever X value on the graph, your Y values get close to whatever Y value on the graph. And people read this, the limit as X approaches C of f of X equals L. But again, what I've written right here is what that means. The big thing I want you to do, write down real big on your paper, because after I teach you some more stuff, people tend to get confused on the easy stuff. So the answer to a limit is, limit is a Y value. The answer to a limit is a Y value. So when you are looking for answers to limits, your answer is always going to be a Y value, not an X value. And that's going to be particularly important as we do the graphical things today. Okay, for our first couple of examples, I have this graph of f of x, and we're just saying it starts at -3 and it ends at 6, and this is the kind of basic shape of it. And so I'm going to answer each of these graphical limit questions. So the first one is the limit as x approaches -1 of f of x. So -1 is the x value right here, and again the answer to a limit is the y value. So what is the y value at -1? That is 0. Then our second question, as x approaches 2. Well, x equals 2 is right here, and so I'm looking at the graph and I'm saying, okay, what is the y value? Well, right in that area, that y value is 1. So the y value is 1 there. And then for our third example, we have the limit as x approaches 4 of f of x. 4 is right here. So what is the y value here? And obviously it's at 2 over here. So our y value is 2. So the answer to these limits are 0, 1, and 2. Not all graphs are this simple. Okay, because all graphs are not simple, sometimes we want to talk about one-sided limits. That means just from one side. We want to look at what the y value is close to or touching. And so what's changed here is that I have this little plus or this little minus after the C, after the number. And don't get this mixed up with in front of the number. In front of the number is your regular positive and negative. After the number is what's telling you the direction. A plus means that you are coming from the right, and a minus means you are coming from the left. Okay, so this is especially helpful if there's something like a jump in the graph when you just want to look to the right or to the left of that point and see what those y values are close to or touching. Now, sometimes they will be the same thing, and that's fine. So let's do some examples. Okay, so now we're going to look at this graph of g of x, and it has some issues. But the first thing I'm going to do is answer these questions about 1. In all of these, we are doing x approaching 1, which is right here. So for number 4, this is x approaches 1 with a plus, which means from the right side. So that means don't look way out here. We're supposed to be approaching 1. It's really close. So right here is where you're looking. What are our y values going to? Well, they're going to 1. So that's what your answer is. Then for 5, you want to approach 1 from the left side, because this is a negative after the 1 telling us to come from the left. And again, I don't want to be way down here. Even though this is to the left of 1, I'm supposed to be approaching 1. So I'm supposed to be to the left side of 1, but really close, like traveling close to it. What are my y values close to now? Again, 1. Now, when we go to number 6, this is back to what we were doing in the first example, where it didn't have right or left. The limit as you approach 1 from both sides is 1. Everything is coming to 1. And so that answer is 1. This will match these two answers if they match. So if you have the right side going to something and the left side going to that same thing, then the limit without a left or right is that number. 7 is actually, you probably are a little confused, but this comes back to our function unit. It doesn't have a limit with it. This just means the point. What is the point at 1? At 1, the point there has a y value of 1. So everything matched on this screen. All right, now let's do something that doesn't. Okay, now for this set, we're looking at 2. All of these are at an x value of 2. So for the first one, number 8, we are looking at 2 from the right. And so again, I'm not way down here. I'm approaching 2. And so as I come from the right-hand side going to 2, I'm looking right here. What are my y values getting close to? And that should be 4. Don't overthink it. The left side is over here. And again, don't be down here. Be close to the 2, thinking about what those y values are getting close to. And in this case, that is 2. Now these are different because there's a jump in the graph. So one side's going up here, one side's going right here. They don't meet. So for number 10, when they ask the limit as you approach 2, if they don't meet, if they're not the same thing, you have to put does not exist. DNE, short for does not exist. And again, you can know that just from doing the math here because these two numbers don't match. So this cannot exist. That limit has to go to the same number in order to exist. Now, g of 2 is where the point actually is. So there's an open circle up here, and there's a closed circle down here. And it can obviously only be one place and still pass the vertical line test. So g of 2 is where the point actually is, and that is at a y value of 2. Okay, I want you to try to do 12 through 15, pause, and see if you can do them without me telling you exactly where you need to do. And then I will go ahead and do the answers. Okay, so the limit as you approach 2 from the left, 2 is right here. And coming from the left-hand side, we are right here getting close to that point. That y value is getting close to 3. 2 from the right side, again, the right side of that would be right here. Heading this way, the y value is getting close to 3 again. And so if they ask the limit as we approach 2 without a right or a left, then because they're both going to that same y value, that is your answer at 3. Now this one's a little different because it asks age of 2 and the point is not there at 3. It's an open circle, so that point does not exist. However, the point is moved down here, kind of below it, and the y value of that point is actually 1. So that would be how we'd answer something like that. Okay, for the last, or the next to last couple problems, I want to talk about infinity. Here, when we have x approaching infinity, it's obviously something that you can't just nail down on a number line. So this means as you go toward the right on the graph. And all I want you to look at is the very right end. What is happening there? And as we go to the right, this graph is going down. And so the y values would be negative and get more and more negative. So you could say negative infinity would be the y value or the answer to that limit. Because that's not an actual number, sometimes you will also see it described as does not exist because you can't pinpoint a single number that it goes to. So either one of those is an acceptable answer, and you may see either one of those in a multiple choice situation. For 17, we're having x go to negative infinity, which would be to the left on the graph. And again, I don't want you thinking about the middle. I want you to think about the very end. What's happening on that left end? Well, these y values are going down forever as well, so that would also be negative infinity. And again, that could be also written as d and e does not exist, because that doesn't give us a single number to nail down. But think of this as right and left. Think of these as up and down answers. Okay, I just wanted to do one more problem with the infinities because it was a little different. Think about your toolbox function, and this is the toolbox function y equals a to the x. It's your exponential growth crosses the y-axis at 1. If we're looking at x going to infinity, which means the right side, thinking about this end, this goes up forever, not down. And since it's up, we could say positive infinity, or again, because it doesn't hit one single number, you could put does not exist. However, when you go to the negative infinity, which means going to the left, and you're thinking about this end, what are the y values getting close to? Well, in this case, there's a horizontal asymptote, as with every exponential function. There's a horizontal asymptote, it's approaching, and it's getting close to 0. So that one actually has an answer. So not every limit at infinity problem is infinity, negative infinity, or does not exist. Some actually have numbers as their answers, and you need to think about what's going on the ends of the graph. This concludes this video. You can see me for your assignment.